Before we start getting into looking at the different types of RCDs and how to test them, it may be a good idea if we spend some time learning how they work. They're basically a fairly simple device. They're what's called a differential device. They measure the amount of current going in and the amount of current going out. So let's have a look and see how that works. Let's look at a very simple comparison. Here's your garden hose coming in through a tap, and it comes back through a sprinkler. When you turn the tap on, water is going to flow down there, and the same amount of water must be flowing there, because it's not going anywhere else. You must have exactly the same amount going there as you've got coming back there. So what you could do, you could put a flow meter in there and a flow meter in there and compare the two flows. They should be the same. But if the naughty dog came along and chewed a hole in the hose here and let some water out, the flow here would be different to the flow there. So this meter would be reading down there. By comparing the two flow meters, you could tell how much water is leaking out through where the dog chewed the hole. Fairly simple principle. So let's see if we can do something with that in electrical terms. Okay, here's your active, and here's your neutral, here's your switch, there's your load, and there's your neutral coming back out. Notice the neutral isn't switched. So now if we turn the switch on, current will flow in the circuit through the heating element or whatever it is, and return back through the neutral. Now, all of the current going in here must also return here because it can't go anywhere else. So what we could do, we could put an ammeter in here and we could put an ammeter in there. And the flow on the two would be the same. But if this somehow went down to earth, say somebody touching the element and touching earth at the same time, the current flowing through here to that point would be different to the current flowing in this point. So therefore this meter would read differently, and somebody looking at the ammeters could think, oh dear, there's electricity going where it's not wanted to, and turn the switch off. Fairly simple principle. But we can't have somebody standing there watching the 2 meters all the time. So we do something differently. Here's your active coming in, goes through the switch, goes through the load, and comes back through the neutral. But we put the neutral together. And around here we put a very tricky device called a current transformer. Now a current transformer is the same as any other transformer, it's just wound slightly differently. And it measures current flowing through here. Now if the current through there is the same as, if the current going down there is the same as the current coming back, the two magnetic fields oppose each other and cancel each other out, so there is no magnetic field there. But if somebody goes and touches the element and gets electrocuted, there is now current flowing through there, so there's less current coming back here. It creates an imbalance in that CT, which triggers a trip mechanism, which automatically opens the switch. And that is how an RCD works. It just measures the difference between the current going in and the current going out. If it's different, it trips the switch. Alright, so this time we're going to have a look at some protection devices. I have a range of them here. Some are people protection, some are circuit protection, and some are over voltage protection. There are basically three types. We'll deal with the over voltage protection first, surge protection, metal oxide varistor, voltage dependent resistor, whatever you like to call them. This is a switchboard mounted one, DIN rail mounting. It just sits on your switchboard. It's got a green light there, and its purpose is to clamp any voltage above about 375 volts. If it gets damaged, in theory that will turn to red and tell you that it needs to be replaced. So that's the surge protection or voltage dependent resistor. Next we have the circuit breaker. A circuit breaker is an overcurrent protection. It is used to protect circuitry, wiring and equipment. It is not to protect people. It does one thing and one thing only. When the current exceeds the rating, this one is, can't see a rating on it, probably 10 amps or 15 amps. Once it exceeds that, it will trip and open the circuit. 20 amps, sorry. It'll trip and open the circuit. That's all they do. You can't test them, and they don't have a test button. These are the ones that you guys will be mostly interested in. These are RCDs, differential protection, safety switches, earth leakage circuit breakers, whatever you like to call them. They've got a million different names, but they all do the same job and they will all work in a very similar manner. I'll give a brief description after this on how they work, but for now we'll just assume that they do. Every RCD, no matter what type, how big it is, what the current rating is, has things in common. They protect people. And they all have a test push button of various sorts. There's a little blue one with a little T on it. This one is a red one with a test on it. This one is a black one with nothing on it. And this one is a white one with test. As I said, they'll come in a variety of sizes. This is just a representative sample of some that you might find in the workshop at any one time.